This is the definition of Rolle's theorem. Let f be continuous on the interval ab and differentiable on the point ab, and f of a equals f of b. There exists at least one c on the point ab such that f prime c equals 0.
For example, apply Rolle's theorem to f of x equals x squared over x squared plus 1 over the interval of -1, 1. First, take the derivative of f of x. F prime of x equals x squared plus 1 times 2x minus x squared times 2x all over x squared plus 1 squared. Which equals 2x over x squared plus 1 squared. Now plug -1 and 1 into the original equation. Which equals 1/2 for both. Now plug in c for x and the derivative. So that would be 2c all over c squared plus 1 squared. Which comes out to c equals 0. So f prime of c equals 0. And that's Rolle's theorem. Apply Rolle's theorem to f of x equals x squared minus 5x plus 4 and the interval 0, 2. First, make sure it is continuous, which it is. Second, make sure it's differentiable, and it is. And it's f prime of x equals 2x minus 5. Now plug in f of 0 and f of 2. F of 0 equals 4. And f of 2 equals -2. Now, because of f of 0 and f of 2 are not equal, Rolle's theorem cannot be applied. So Rolle's theorem does not apply because f of a does not equal f of b. Mean value theorem says, let f be continuous on the interval ab and differentiable on the point ab. There exists at least one c in ab such that f prime of c equals f of b minus f of a all over b minus a.
Apply mean value theorem to f of x equals x squared on the interval -2, 1. First, you want to make sure the function is continuous and x squared is continuous. Next, you take the derivative of x squared. So f prime of x would equal 2x. Then you have to check and make sure your derivative is differentiable, which it is. Next step is you take your interval, so you plug in a -2 into your original equation, and that will give you 4. And then f of 1, which would equal 1. And then you would take the here. Next, you take f prime of c equals f of b minus f of a all over b minus a. So your f prime of c would be 2x when substituting the x as c, so 2c. And then you would set 2c equal to, so your 2c would equal 1 minus 4 over a 1 minus a negative 2, which would equal a negative 1. So 2c equals a negative 1. You would divide out the 2, making your c equal a negative 1/2. Apply mean value theorem to f of x equals x times x squared minus x minus 2 on the interval -1, 1. First, make sure your function is continuous, which it is, and then distribute your x. So you would get x cubed minus x squared minus 2x. And then you would differentiate it. So f prime of x equals 3x squared minus 2x minus 2. And then double check and make sure it's differentiable, which it is. And then you would take the points of your interval and plug that back into the original equation. So your f of -1 equals 0, and your f of 1 equals a -2. And then you would take f prime of c, so you're substituting the x with a c in the differentiated problem, equals f of a 3c squared minus 2c minus 2. And then set that all equal to f of a minus f of b all over b over a. And that equals a -1. So then you will factor the 3c squared minus 2c minus 2, which would give you 3c plus 1 multiplied by c minus 1 equals 0. So your c would equal a -1/3 and 1. But your c cannot equal 1 because that is one of the points on your interval. And that's mean value theorem.